x equals a.
Yeah, and keep going.
So would you do a over 1 equals sine x?
It's already a over 1.
Um,
So sine x would be
a.
it's already a. A and a over 1 are the same.
1 over a.
Yeah. And so x would equal?
So x would equal arc sine 1 over a.
Yes. And so you can do that right from the start if you want to solve like cosec x equals something. Or you can do it like an intermediary step. Just say sine x is equal to 1 over a, and then go from there. So if cosec x is a, then sine x is 1 over a.
Okay.
Okay, so what are these three then?
So cosec a we found is we found it earlier. Sec is 1 over cos x equals a. So x equals arc cos 1 over a.
Yes.
And cot is 1 over tan, or sine over cos. Would it be better to write it 1 over tan?
Yeah, for solving it, yeah.
Okay. So then that just becomes x equals arc tan 1 over a.
Yeah. Okay, great. Okay, solve this.
Okay. So x equals inverse cos 1 over 2, so half. And then you solve that. And that's a third pi. And then you can look along the sine graph and see where that gets.
Okay.
So that's a third pi, and then pi minus a third pi, which is equal to 2 over 3 pi.
Yes, and it's always going to be pi minus the first answer.
Yeah.
And so that is 2/3 pi. So 1/3 pi and 2/3 pi. That's 1/3 pi. And hold on a second. No, this was cos, so it's not pi minus. It is.
Oh, it's cos. Oh,
Yeah.
I drew sine by accident.
Yeah.
So it's 2 pi minus.
Yeah. So what is that?
So that's 5 over 3 pi.
Yep. 1 2/3. Okay. How about this?
Cosec squared x. So that's 1 over sine squared x equals a. So sine squared x equals 1 over a. Would it be x is equal to arc sine, then the root of 1 over a?
Yeah. And what happens how many solutions will there be?
Well, there will be a plus and a minus solution.
Yeah,
So 2.
that's it. And I think you'd be fine for those 3. It's the same idea.
Mm-hmm.
Okay, let's try this.
Three. So cos is 1 of tan, so over is 3. Theta equals arctan root of 1 over 3. And it's plus minus.
Mm-hmm.
And that's 30. Then you look at tan.
Mm-hmm.
And if you look to 30, you do one. You do minus 180 plus 30.
What do you get?
Minus 150.
Okay.
And those are the 2 values I get.
And what was this with the plus or minus?
So then there's minus 30 as well.
Mm-hmm.
So that's minus 30 and 150.
Yeah.
So, yeah.
That's it. So theta minus 150, minus 30, plus 30, and plus 150.
Mm-hmm.
Looks good. Yes. Okay. I think you'll be fine there. Fine. How would you start question D?
Question D, I would divide by 3, both sides.
And what would you get?
I'd get cosec squared x equals 4 over 3.
Yeah, and then it would just be fine to go from there.
Mm-hmm.
Mm-hmm. Yes, so this is the identities. So which, let's see, the trick to solving mixed trig quadratics is to make the trig terms all the same. Ah, yeah, so sec squared x and sec x, tan squared x and tan x. So which trig identity does the first one match up with so that you could swap values out?
The first identity being solve 2 tan squared x.
So that's there, yep. This one? I'm not too sure what's going on. We'll just skip ahead and see how we do. So this one, how do we solve this? 2 tan squared x minus 7 sec x plus 5 equals 0.
You would sec is cos, right?
Yep.
So you could do 2 tan squared x minus 7 1 over cos x plus 5 equals 0.
Okay, so you have a mixture of tan and cos. What do you do about that?
You change tan into sine over cos.
Okay, then you have a mixture of cos squared and cos
Yeah.
and sine.
I'm not too sure.
Use this identity up here to get either everything as tan and tan squared or everything as sec and sec squared.
Okay. So there's obviously the tan squared x. Oh, so you substitute in 1 plus tan squared x for sec x?
Well, sec squared x is 1 plus tan squared x.
Oh. Do you square everything?
It might be easier because we have a tan squared x to get this one up here in terms of tan squared x.
But we don't have a 1 plus. So how would that happen?
So just move the 1 to the other side. So it's tan squared x equals?
Oh, so tan squared x equals sec squared x minus 1.
And how can you use that?
So you rewrite it as 2, then bracket sec squared x minus 1, close bracket, minus 7 sec x plus 5, and then you make a quadratic formula.
That's it. Okay, let's try that.
So 7 sec squared x minus 7 sec x is 5.
How did you get 7 sec squared x?
Oh, I wrote the 2 and it looked like a 7. Okay, so you get 2 sec squared x minus 7 sec x plus 3 equals 0. And I'm using my calculator to solve that. And the answers are 3 or 0.5.
Is that it?
Do you look at the sec graph?
So basically, so it's not x equals, it's sec x equals those two. And then you just solve them separately.
Okay, so 1 over cos equals 3. So x equals cos, arc cos 1 over 3. Or x equals arc cos 1 over 0.5. And yeah, you solve those. So the first one is 70.53.
And the second one, actually, it won't be arc cos 0.5. I believe it'll be arc cos 1 over 0.5.
Yeah.
Which I believe is 2.
My calculator doesn't like that. It won't do it.
Why not?
It says non-real.
Why is there no solution for arc cos 2?
Because it's greater than the limits, the boundaries.
Yeah, cos graph only goes up to 1. So that's outside of the range. And so, is that everything? Yeah, I think we can stop there. 70.53 or 70.5 degrees. They didn't ask for us. They didn't give us the boundary, so maybe if it was cos, we'd do 360 minus and get a second answer if they asked for it. Yes, so the reason why we use this identity is to get it as everything tan or everything sec so that we can solve it. So let me go back. So going back here, so this is the one we did, and that matches up with this identity. So what would you do? Which identity would you use for the second one?
Oh, you cut out.
Sorry, which identity would you use for the second one to get them all as cosec or cot?
You cut out for like half a minute.
Oh, sorry. So the way we just did that one, we used this identity on the right
Mm-hmm.
to get everything in terms of tan.
Sure.
Sorry, everything in terms of sec. And so which of the two identities would we use for the second one?
So you'd use the left one for the second one.
Yeah. How about this one?
The right one.
How about this one?
That one is looking at cot. So possibly on the left if you square everything.
I think it's neither actually. That's just 1 over tan. So I think that's just going to be tan anyway. So I think you don't need anything for that. Did I put that
Okay.
one down as? Yeah, I didn't put it down as anything. Okay. How do you do? No. I think we're fine there. Yeah. How do we do this one?
Okay, so that one is 3, 1 over tan.
Yeah. So I'll try it as 3 over tan x.
Yeah. So 3 over tan x plus 2 tan x equals 5.
Hang on. Before I make you do that, maybe we should practice this a bit more. Don't just gloss over it. So we had these two identities. Why is that not working? Oh yeah, because I'm using this thing. Copy that. That goes there. Paste. And I think... So let's solve this one. So that is equal to 0. Solve.
Okay.
No, that's too easy. Hold on. Cosec, sec, da, da, da. Yeah, I can see why I did it that way. Okay. Hold on. Yes, let's do this one.
Okay. So tan squared x plus sec x equals 1. So we can turn the tan x into sec squared x minus 1 plus sec x equals 1. And we solve the quadratic equation in radians. Okay, so 1 times 1. Minus 2. So I get 1 and minus 2.
As x or sec x?
Sec x.
Okay.
So then x equals inverse sine 1 or inverse sine a half minus half.
Okay.
So the first one's a half pi.
And how did you get that half pi? Inverse, what was it?
So it was inverse sine.
What is sec?
Sec is cos.
Yes.
Yeah. So 2 over 3 pi. Oh wait, that's for the half one. Minus half is 2 over 3 pi. and the 1 is 0.
Okay, so we want all solutions between 0 and 2 pi.
Okay, so we're looking at a cos graph. So at 0, it will be at, wait, so at 0, it could be also at, what's it, pi over 2 and 3 over 2 pi.
And how did you get those?
By look at the graph, and if you look at 0 and draw a line across, it stays on the x-axis.
For cos, the second answer is always 2 pi minus the first answer.
So it will be 2 pi.
Yep. And second
one? And that's 2 over 3 pi. So it will just be 2 pi minus 2 over 3 pi.
Yep.
Which is 4 over 3 pi.
Well done. Yes, so you had to use the identity to swap it out. So it's a quadratic, and then you just solve it from there and just kind of keep an eye on it. So it gets tricky. Sec, just look at the third letter. It's a C, so it's cos.
Mm-hmm.
And our cos of the reciprocal. 0, 2 over 3 pi, 4 over 3 pi, and 2 pi. Any questions about that one?
Nope.
Okay. This is shown. Okay, that one we don't need. Yeah. Let's see this one. Is this worth doing? I suspect you'll be okay for these now. Let's see. Let's do this one. We haven't done one of these.
So minus pi. Pi. Substituting code. By substituting 4 cots in terms of cosec. Okay. Oh, so it means use the rule that's written below.
Mm-hmm.
So we want it in terms of cosec, so it's 2 cosec squared minus 1
Mm-hmm.
plus cosec theta plus 1 equals 0. And you solve the simultaneous equation.
Quadratic equation?
Yeah, quadratic.
Okay.
And it's 0 and minus 0.5.
Okay.
So that's cosec theta equals 0 or minus 0.5.
Mm-hmm.
So you solve it, which is inverse sine 1 over 0, which is still 0, or 1 over 0.5 minus 0.5.
Okay.
And the first one gives you 0.
Did you put into your calculator arc sine 1 over 0?
Yeah. 1, 0. No, maths error.
Why is that?
I'm not too sure.
You are dividing by 0. Can't do.
Oh. So it would be nothing.
So no solutions there.
Okay. And the second one is non-real.
Yeah, so 1 over, that's 2, is it?
Yeah, -2.
Ooh. Are there any
Um,
solutions? There might be. Let's see. Did we go wrong somewhere here? So 2, should be. What did you put in as the quadratic?
as the quadratic, I did 2, 1, 0.
Last one shouldn't be 0. When you
Um,
expand it, you should get -2.
Oh, -2.
And then +1.
Yeah, so it's -1.
Yeah.
So 0.5 and 1.
Okay.
So the second one still,
Yeah.
it's too big. And the other one is just a half pi.
Okay.
And then to solve for the other solutions, there aren't any others for half pi on the sine graph.
Yeah, so that's just one repeated one, isn't it? 0 equals theta equals a half pi. Yeah, great. Oh, hold on. This is between pi and minus pi. Does that make a difference?
No,
So
because
it repeats every 2 pi, doesn't it?
yeah.
Let's see. So how could you get a second solution? Or a third, I suppose.
There's no plus minuses anywhere, so no.
If it repeats every 2 pi, you could take away 2 pi.
Oh yeah. So 3 over 2 pi, but that's still too big.
So you've got -3 over 2. Yeah, it is. That is too big. Yeah, so it is. It is just one repeated solution. Yeah, okay. So theta is equal to pi over 2. Great.
Okay.
Any questions there?
No?
Yeah, so just watch out for that quadratic. Let's see.
I have an example here.
Yeah.
Maybe having done with this will be easier, but I'll just read out. It's sec and bracket 2 theta plus pi over 3 equals 2.
Yeah. So sec 2
Then,
theta plus pi over 3. Yep.
Equals 2. And the range is 0 to 2 pi.
Okay, so what do you think now?
So first I expand the bracket.
That's not possible. This isn't times, this is the sec of that.
Okay. So then it's 1 over cos that whole bracket equals 2. And then cos the bracket equals 1 over 2. So then this bracket, 2 theta plus pi over 3 equals arc cos 1 over 2. From here, do you subtract pi over 3 from both sides?
You get all the solutions first and you only do that stuff at the end.
Okay. So you'd figure out arc cos a half, which is a third pi. and then you find all the other values as well,
Mm-hmm.
which is pi minus 2 pi minus that. So 5 over 3 pi.
Mm-hmm.
Yeah, that's in the range. So then from here, you add pi over 3 to both of them.
It's already add pi over 3.
You subtract pi over 3.
Yeah.
So 0.
Yeah.
And 4 over 3
Yeah.
pi. And then you divide those by 0, by 2. So the first one is still 0. And the second one is 2 over 3 pi.
Yeah, that's it.
Okay. Yeah, that's fairly simple.
Okay. Yeah, so it's not because of the way it's written, it looks like it's times, but it's just the sec of those things. And you keep, once you've done the inverse sine, cos, or tan, you just keep everything as it is until you've gotten all your solutions because the graph has been transformed.
Yeah.
Okay, exam question. Do you know how to do this first one? First to prove that thing.
Given that sine square theta equals cos square theta 1 plus.
Actually, let's do B first, and then we'll do A second.
Okay.
And you can obviously use A to do B.
Sure. So 2 cos squared theta minus 9 cosec theta equals 3. Plus cos squared theta equals cosec theta. So 2 cosec squared theta minus 1 minus 9 cosec theta minus 3 equals 0.
Mm-hmm.
No. So 2 cosec squared theta minus 9 cosec theta minus 4 equals 0.
Okay.
And that you put in the calculator.
And what was the number at the end?
Minus 4.
So when you expand the bracket, what do you get?
Oh. Aha. I didn't expand the bracket, so it's minus 2.
Yes.
So it becomes minus 5.
Yes. So you did the same thing last time, so just watch out for that.
So cosec theta is equal to 5 and minus 0.5. So the second answer we can already discard because we know that will become minus 2. So theta equals arc sine 1 over 5. Arc sine 1 over 5 is I'm still in radians. 11.54.
And so it's one decimal place.
So 11.5.
That's it.
And there's only going to be one value up until 180. Actually, no, there are two. It's 180 minus 11.5, which is 168.5.
Is 11.5 and 168.5. That's great. Do you know how to do part A?
Yeah, that sounds good.
Right.
So that 1 cos square theta equals cosec theta. No.
So let's do. I might have put it. It might come later. I might have just put it in the wrong. No, it doesn't look like it does. It's my own mistake. So the way we do it, sine squared theta plus cos squared theta is identical to 1. I don't remember which one, but it'll work for one of them. You either divide everything by sine squared theta, or you divide everything by cos squared theta. So we'll start with sine squared theta. What do you get?
Oh, this makes sense. Yeah, I think it is the sine squared theta one that does this. So if you do that, that gives you 1 plus tan squared theta, which equals 1 over sine squared theta.
Well, it's not tan squared. That's sine over cos.
Oh,
this is cos over sine.
It's cos over sine, so this is cot squared theta. So 1 plus cot squared theta is the same as cosec theta.
Yes, and on the right side you have 1 over sine squared theta, and that is the same. 1 over sine is cosec. And so 1 over sine squared theta is cosec squared theta. And we've proven it. There we go. So it was, dividing everything by sine.
There was a follow-up question to this, because I found a sheet with this on, and it says, if cot theta equals 3 over 4, find the possible values of cosec theta.
Yes, so that's next. We'll skip ahead. Just because you've brought it up. That would be next. So if cot theta was it 4 over 3?
3 over 4.
3 over 4. Then we want exact value of cos theta?
Of cot theta.
What did they want, sorry? Exact value of?
And they said find the possible values of cosec theta.
Cosec theta. Cosec theta. Okay. Put this back in terms of tan.
Okay. So 1 over tan theta equals 3 over 4. So theta equals inverse tan.
No. What is tan theta equal to?
Tan theta is equal to 4 over 3.
Yeah. So maybe that way will work, but what's better is exact values. We could do it. I'll just leave it like this. In terms of SOHCAHTOA, what is tan?
Tan is opposite over adjacent.
Yeah. And so, opposite over adjacent, we sketch a little triangle, and I'll pick the bottom left corner to be theta. Opposite side is 4, the adjacent side is 3. What is the remaining side?
So it's 4 squared plus 3 squared, so 16 plus 9, 25, so 5.
Yep. And so what is cosec theta?
Cosec theta is equal to 1 over sine theta.
So what is sine theta in relation with this triangle? And so what is 1 over sine theta?
So sine theta is opposite over hypotenuse, which is equal to 4 over 5.
Okay.
So then that means that cosec theta is 5 over 4.
Yes. hypotenuse over opposite. 5/4. And there's a little trick. So this is just one method for doing it. If you were using the sine squared theta plus cos squared theta is equal to 1, you would in the end get plus or minus. The other possibility is the quadrants. So you know when you do the quadrant thing and you have the that thing?
Yeah.
So we have the tan of theta is a positive number. So it's either in the first quadrant or it's in the third quadrant.
Mm-hmm.
If it's in the first quadrant, then sine theta is 4/5. If it was in the third quadrant, what do you know about sine in the third quadrant?
It's negative.
Yes. And so we don't know which quadrant it's in. It's either the first or the third. And so that's why it's plus or minus 5/4.
Mm-hmm.
It's
Okay.
if it's in quadrant 1, it's 5/4. If it's in quadrant 3, it's negative 5/4.
How do we know which quadrant it's in again?
We don't. We know it's in either the first or third because the tan of theta gives us a positive number.
Right.
Tan is positive between 0 and 90 degrees and 180 and 270. And so we know that if it's between 0 and 90, then sine is 4/5. If it's between 180 and 270, it's minus 4/5.
Mm-hmm. Okay.
Yeah, and we could do inverse tan. I wonder, does it give you an exact value? Inverse tan 4/3. So they usually ask for an exact value. Yeah. So that's what theta. So if we did sine of that value, sine answer. There you go. So it would have worked if you'd done it with your calculator.
Okay.
Not great practice. Okay, let's do it with the calculator. So
Sure.
tan theta is 4/3.
Mm.
I suppose I just did it. So inverse tan 4/3 is this.
Yeah.
And so if we do sine of the answer, sine theta. So that is theta. We just found theta. And so sine theta is 4/5. And so cosec theta is 5/4.
So sine. Ooh, this is strange. So sine of the answer for inverse. Oh, it's sine theta.
Yeah, because so tan theta is 4/3.
Yeah.
Theta is 53. And so sine theta is sine answer because the answer is theta.
So sine theta is, what's it? What did it give you?
4/5.
4/5, yeah, and then cosec is the other way around. Yeah, okay, I get that.
And I suppose the only trick though is the remembering that. Now I kind of skipped ahead because you mentioned it, but I do go through all that. Let's just see. Here's a proving thing. Let's try this.
Okay. So cos x 1 sine x plus 1 plus sine x cos x the same as 2 sec x. Okay. And sec x is 1/cos x. So that's essentially what we're trying to get, right?
Yeah.
Could I'm not too sure.
I think add these two fractions, so they're one fraction.
So cos. Oh, you need to common denominator. So cos squared x over cos x brackets 1 plus sine x squared, except both sides, plus 1 plus sine x squared as well. Um,
And what was the common denominator?
and does that just give you... so the bottom is cos x brackets 1 plus sine x squared.
I believe it's just 1 plus sine x, not squared.
1 plus...
You just multiplied the two by each other.
oh, yes, yeah.
Yeah, okay. I think simplify the top.
Simplify the top. Could you... well, 1 plus sine x squared.
Yeah.
That becomes... so the whole top is cos squared x plus 1 plus sine squared x, which can be rewritten as cos squared x.
Slow down. That's bracket squared is the same as times itself. So 1 plus sine x times 1 plus sine x. So you got the first, you got the last.
No, sometimes when you see squared, you just think you could multiply it through. But,
Everyone thinks that.
so it's 1 plus 2 sine x plus sine squared x.
Yeah.
Over cos x plus... oh, cos x, yeah, times 1 plus sine x.
Yep.
1 plus sine squared x is the same as cos squared x, right?
No, 1 minus is.
1 minus. Oh. Would you be using that in this case?
Yeah. But not that complicated.
I'm not too sure what goes on.
What is sine squared x plus cos squared x?
Oh, 1.
Yep.
So it's 2 plus 2 sine x over cos x 1 plus sine x.
Mm-hmm.
Do you factorize it?
Sure do.
So 2, 1 plus sine x over cos x 1 plus sine x. And then from here, do you just cancel out the 1 plus sine x's from top and bottom?
Yeah.
So you're left with 2 over cos x, which is the same as 2 sec x.
Yeah. How do you do part B?
Part B. Let's find 0 x 2 pi with all the solutions of that equals 4. So we know that that equation can be simplified to 2 sec x equals 4.
Mm-hmm.
So sec x equals 2.
Mm-hmm.
So x equals inverse cos a half.
Mm-hmm.
And you solve that, which gets you 60.
Radians?
Oh. Which gets you a third pi. And then you do 2 pi minus a third pi, which is equal to 5 over 3 pi.
That's great. 5 over 3 pi. Well done. Great. Yeah, so cancelling down the thing, fully simplify, fully factorize. And then for part B, use part A, the hence thing. And then there's a bunch of questions, but those were the exam questions for that. We just touched a little bit on the other stuff. Yeah, but we did it. You're okay. I think that would be something to look at, the quadrants thing.
Yeah, definitely.
But the quadrants thing is just a simplification of the trig graphs.
Yeah, yeah.
Um,
It's
I could go looking for them. Take a look. What chapter was this one? Core 3. This is probably in chapter 6. Did I just download this? 6A and 6B. See, I just have a nice little thing for it. So there, might be chapter 5. Yeah, probably is chapter 5. Is this one I'm in? It's not there. Chapter 5. Old versions. I don't think it's this. No. There it is. Kind of. I'm missing the trig graph, but basically, how else? Let's see if I. Yeah, so this is where I go through the whole reciprocal thing. Yeah, that's where I go through the whole reciprocal thing. But basically, you can see how the sine graph is positive between 0 and 180. Cos is positive between 0 and 90 and 270 and 360. And then tan is positive between 0 and 90. So they're all positive between 0 and 90. From 90 to 180, the only one that's positive is sine. From 180 to 270, the only one that's positive is tan. And then from 270 to 360, sine is negative, tan is negative, and you can see cos is positive. And so this just summarizes when each one is positive and when each one is negative. And so I have a little exercise for it, but that's it's just a graph. That's where it comes from. And so
sure, that makes sense. Yeah.
Yes.
Because I didn't properly understand it for the whole of these past 2 years.
Here we go. So this is where I have it. And where is it? Yes. And so if you are told that if you're told tan theta is 2, it's either in between 0 and 90 or between 180 and 270.
Hello?
Oh, can you hear me? Hello? I can hear me?
Sorry, you cut out again.
Oh, okay.
Yeah.
So if it says tan theta is 2, then theta is either between 0 and 90 because it's positive, or 180 and 270. In which case, if it's between 0 and 90, everything is positive. If it's not, then the other two, cos and sine, would be negative. Is it doing it again? Can you hear me? I can hear me? Hello? I don't know what's happening.
I don't know what's going on. Yeah.
I think it's just a connection.
But anyway, my internet is very slow.
How was that for you, Gregoire? Is there anything in particular you want to do next time? Are you able to hear me?
It was good, thank you. Yeah, just about.
Okay.
Uh,
Anything in
go on.
particular you want to do next time?